Hey, hello and welcome to Sharp Juniors Developers. Hey, hello and welcome to Sharp Junior Developers community channel. 3 hours ago, a junior developer shared their job interview experience, where they mentioned the coding task they were given. It sounded like you are given an array, a sorted array, with one element that is out of place. Write a function that returns the sorted array. Now I will solve this task myself and prepare some tests to compare my solution versus AI solutions. Let's go. Okay, first of all, we want to create the console app, name it almost sorted array versus, okay, with tests. Okay, let's make it .NET 10. Interesting. My Visual Studio stopped working. Okay. Okay. So what do we have here? We have console write line. Let's say array sorter, new class, array sorter. Public, let's say int sort array, and it takes array as well. Okay, let's say return null for now. Here we will say array sorter new sorter sort array. Okay, array. Let's say we need a function, first of all, to create our array. It will be an integer array returning function, generate array, int length. Okay, then okay, we know the difference, but okay, let's have it here. Array new int length. For, come on, for I, yeah, we have length. Why don't you like length? The name length does not exist in the current context. It's right here, like 2 rows above, 2 lines above. Why don't you like it? Length. Oh, I see. I've made a typo. Okay. Now it works. Array I equals random new random next. Well, let's say -1000 +1000 Okay, and return array. That's it. What's wrong here? Local function is declared but never used. Okay, we'll use it. Don't you worry. Okay, our array equals generate array, let's say 5. Let's not sort it for now. Let's just okay, void print array int array for, come on, array length. Yeah, I guess we just want to use write. We'll write I plus, or let's do it this way, maybe. Okay, it doesn't really matter. Firstly, I wanted to use, or yeah, it would be better actually. Let's remove this. Okay. Array to print. Let's say it like that. One of the biggest issues in the programming, how to name things. Okay, array to print equals string John. Why not? String join, just a space and array. Okay, console write line, array to print, and let's print it. Print array. Okay, let's save everything and run our program. Okay, and I will need to, I guess, make a new window capture. Let's name it debug console. Okay, here it is. So as you can see, we have it right here. And also we have hello world. Why not? Okay. So var result. And we can also print, no, wait a second, print array result. Okay, we can do it like that. Let's run. Oh, well, it cannot be null, of course. Let's return just this array. We'll close this for now. Let's run. Yep, result is the same. We can also say original array. Okay, now it seems to be in order. Okay, we don't need this anymore, we don't need that. Okay, let's write our sort array function. Actually, before that, I want to make this one public. Okay, add new project. Okay, almost sorted array dot tests. .NET 10, of course. Let's move it here. Okay, the names are not aligned. Let's make it like this. Now it's better. We want to manage NuGet packages. Install XE unit, let's say up, not here. The latest one, right? Yep. Okay. Okay. Give it a second. Okay, I'm back. Sorry for that. Okay, I'm here. Array sorter. Array sorter tests. Public void. Okay, let me think. What method do we have here? Sort array. We don't need to use array here. I actually can name it get sorted. Or just sort. Okay. We will need to rename it here. Okay. Sort empty returns empty. Okay. Oh, and we also need to rename it, right? Okay. Okay. Right. Oh, okay. We need to add project reference. Array sorter. Come on. Or just system under test. I'm doing this wrong, so let's fix it. What test do we want? We want empty array, null array, just null. We want Okay, we can't use fully sorted array. We can use one element array, two element array, and let's say normal array. Oh, that's interesting. Okay, according to our task rules, let me place it here. You are given a sorted array, and this does not specify do we have duplicates or not. So there might be duplicates, and that's good for our generate array function. But we also need one more thing. Let's say int. Not prepare. That's the bad one. Get almost sorted array. So what do we need here? Array dot sort array. Okay. Now random new. Do I really need to create another random? Random next. I can specify just max value, right? Yes. Array.length. Okay, var, let's say I, the first index, while okay, let's say j equals j equals random next array length. Well, I not equal j equals j. Okay. I wonder, will it work here? I know for sure it works in Python, and most probably it works here as well. Let's see. Oh, maybe not. Not sure. Okay. Array I, array j equals array j. Oops. Array j, array I. Okay, so we swapped it. We can return the same array, but I'm not sure why would we want to do that. So let's say void make almost sorted array. Okay. Let's see. Original array here. Let's say we don't need this for now. Make almost sorted array. Oh, we don't need this either. Print array. Okay, let's see. Okay, so what do we have here? We have just normally sorted array. Yep, it didn't swap any elements. Because this one's int, this one's int, yeah, and they just okay. Temp equals array I. Array I equals array J. Array J equals temp. Okay, let's see. What happens? Why it doesn't? Change anything. Okay, let's debug. So what do we have here? Locals I and J both are 0. Why? Why is that? Oh my. Now I get it. Okay. So 4 and 1. Come on. Yep. It switches. Oh, no. Or yep, it switches them. We don't need that. That's not that easy. Okay, let's check our previous version. Will this work? Okay, it does not. Oh, wait a second. No, wait. Ah, okay, I ruined it. But, you see, it works. It changed this to numbers, I guess. Let's do it again. Yep. Change this to swap them. Wow. How did you do that? Okay. But we don't need to swap them. We want now we need another integer array. We want to sort it. We want to take this I. Okay. So we don't need this swapping at all. What we want to do here is okay, we want to split our array. Let's say it's like 1, 2, 4, 5, 6, 3. No. Let's say it's like that. We take I or j. Okay. Our left is math min ij. Our right math max ij. So we have a left here, and let's say we have right here. So what we do here, we take this one and want to place it here. Okay, so for I, while I is less than, okay, I can't use I here. Random 1, random 2. That's actually random 1. Random 2. While I is less than left. We create a new array. Result new int array length. Result I equals array I. So we copy the first part. Then we copy the second part. We can do it in one for loop, but just for the sake of clarity, I will make it in 3. Okay, so well, for I equals left, left and less than right. Again, array I. Plus 1, I guess. Okay, this will copy from left to right. Then what we need to insert into result, right, our left, I guess. Array left. Okay, and now we need to copy the last part. Right plus 1 less than array length. Return result. I hope it will work. Let's see. Results. Okay. So what do we have here? We have -452. This one's assorted, and this one moved from here to here. Or actually, -1 was moved. The -1 moved here. Okay, now it works the way they need it to be. Okay, so what do we want here is, I guess, get and then okay, so we generated, we sorted, we are doing everything great. Random, we don't need random here. Okay, get almost sorted array. It's not var result anymore. Array length 5. Array length. Okay. Let's run it. Okay, original array. -957 was here, but it's not there, so everything is great. Yep. Okay. Sounds great. Let's move on. Phew. We prepared get almost sorted array. Let's move it here. And print array. Let's add another class, array helper. We don't need to make it public, it can be internal by default. So what do we want here is to remove these ones, put them there. Okay. We don't have random here, so we can make a constructor. Private read only random equals new, and just rename them. Okay. Great. Now let's check that everything works. Yep. I don't need to use any DI things here to make it even more realistic. Let's leave it like this. Okay, no duplicates, that's not a problem. Maybe we want to check for duplicates. Why not? Array, oops, where's duplicates? Okay, great. So what do we want here? Empty array. Okay. Sort results. Sort new int 0. Array empty, actually, yeah, that's more efficient. Assert empty. Nope. Okay. Array empty results. Okay, the first one, empty array, is done. Let's do the same for now. How many? 5, 2, 3, 4, 5. Okay. Now returns now. We have here now and here now as well. What? Don't use, yeah, assert null instead. You're right. Okay, what don't you like here? Can't convert. No. unnecessary cost. Cannot convert null literal to non-nullable reference type. Oh, I see. And here we need as well. Okay, what's run here? Test method on test class has the same name as another method. Oh, okay. That's just for now. Okay, so this one is done. One element array. One element turns array. Let's say original array. Okay, now we need array. Or actually, one. No? How does it work? Not sure I remember. No. Okay, it works now. What about var? There is no target type for the collection expression. Okay. Let's leave it here. Array. And array is the same as result. Okay. This one's done. Two element array. That might be a better approach. Okay, 2, 1. So sort equals, oh, can I? Not sure I can do it here. 1, 2, and result. Result may be null here. I'm sure it's not null here. Don't worry. 2 elements. Turn sorted array. Okay, and the names again. This might be better to copy. Okay. Plus normal array. Let's say 1, 2, 4, 5, -1. And what we're waiting here is -1. Okay. Duplicates. But it still returns sorted array. Right. So 1, 2, let's say 3, 4, 5, 3. exclamation mark here. Okay, we have our tests. Let's test. Test discovery aborted. Why? 2 errors. Why? What's wrong with it? Could not find test host. Does not reference. Oh, I see. Get X unit. Run Visual Studio. Okay, now it's not. Or I'm not sure about that. Oh, I see. No. Okay. If array is null, array is null. No, wait a second. Break a line and return. Okay, now we are ready. One more. Still couldn't find test host. Okay, let's go out. Let's LLM it. Oh, install package Microsoft Visual Studio Test Platform. Interesting. Okay, now run. Where it tries to find it. Okay. Okay, build succeeded, but I still have this issue. That's interesting. Okay, one more thing we can try here. Tools, options, environment extensions. Tools, options, environment extensions. It's not there. Okay, let's uninstall this one. Install and install the original from Microsoft. Where do I install it? What project is this? Test platform for tests. Okay. Let's try again. Build succeeded, test aborted. The issue is still the same. Can it be because I tried to be fancy and use .NET 10? Okay. What happened here? The specified argument cannot be empty. Test window filters. Okay. One more library here. Let's uninstall it again. And install this one. 1 billion installations. Of course, I agree. Run. Now it works. Okay. Let's get back to our .NET 10. Just to check for maybe some other issues that might arise. It's a good way for me and for you to see what happens if you try to use the preview version of software. Okay, let's rebuild and run our tests again. Great. So we used TDD approach. We wrote tests before our software started to work. Okay. Interestingly enough, these tests that I thought that should fail, that they not failed. Okay, if array is null or array length is less than 2, return array. Or actually, let's do it like the proper way. Okay. I'm thinking, do I need to use a delegate here? And I think I do. Just because we will have other tests here. But okay, let's leave it for now. How will we sort? First of all, what I want is to find an element that is misplaced. That's an interesting task. Okay, misplaced element. Get misplaced element. No, actually misplaced element index. Index. And here we'll pass array. Okay, generate. It will return int and yeah, let's do it for I is less than array.length current equals array 0 and we start with 1. If current is we can omit the creation of an additional integer variable here, but then we will need to do 2 calls for an array element, and I don't really want that. Okay, so get misplaced element index. If current is bigger than array I, return I, which means that the previous element is bigger than the current one. Okay, throw new exception, something went wrong here. Okay, get misplaced element. What do we want next? Okay, let's move through iterations. Misplaced element index, and then just return an array. Okay, and let's see. Okay, so you see, misplaced element is -782, and it's here, so we found it correctly. That's good. That's even great. Okay, this works. Now, what do I want to do? Now we need to find the place where to put this element. Ideally, what I would want to use here is binary search. I'm not quite sure I understand now how to prevent our algorithm from getting the same element. Okay, or new misplaced element index. And actually, let's do it like this, and misplaced element index, generate new method. What? Get misplaced. Okay. Get new index for misplaced element. Something like that. Okay. How do we want to do that? Okay, give me a second. think I had some help here. Okay, just to make it a bit faster. So we have int low 0, int high equals array length -1. While low is less or equal to high, and mid equals low plus high minus low divided by 2. It's an int, so we don't need to round it up or down. So we found the middle element. Let's see if we also want to have the target here. Equals array misplaced element index. Okay. If array mid equals target, what do we want here? Oh, okay, it's array. Array. Why not? I'm going slightly dark. That means that we need to finish soon. Come on, come on, come on, come on, come on. So high equals mid -1. We move our high to the left of the target. Interesting. Okay, let's move on. Array mid is less than target. Then what we do, we shift. We move low equals mid +1. Else high equals mid +1. Actually, if we found the target, I guess I might want to just return this int. Return mid. And if we didn't find it, we return low. Or high, it doesn't really matter here. Okay, let's see. One more thing here is that if we extract the element, then we will need to shift the whole array. Okay. See. Array misplaced element index must be moved to index new misplaced. Let's try it. Something went wrong here. Okay, let's see what we have here. So this element was moved How did we get here? -6 to 4. It's not actually current, it's previous one. Oops. Okay, it's previous. Okay, can we debug here? I guess we need this array. Or just the last one should be there. -6, 3, 4, 5, -5. Let's go. So previous is -6. Current one is no. It's 3. Okay, so we move on. Previous is -6. Oh my. I see the issue now. How did it work before? Okay, original array. see. We've entered the infinite loop. Right. Guess allow 0, high 4. Mid is 2. Remit. And watch. Okay. Remit is 4, target is -5. -5 is the replaced one. Right? So the one that we found is bigger. We need to shift high. Yeah, 4 is, no, here. We need to shift high. High becomes 2 plus 1. Why? -1. My bad. Okay. Let's try it once more. Okay. -5 must be moved to index 1. Now it works. Now it works. Great. Phew. Okay. Who would think that it would be so long? Who would have thought? Almost 1.5 hours. Okay. I'm going more and more dark. Okay. Okay, what do we need here? We need to create a new array actually. So it will be result new int array dot length. Okay, again, int left equals math min misplaced element index, new misplaced element index, and the same goes for right. Instead of min it's just max, and that's it. Okay, again, for I before left, what do we do here? We actually wrote this algorithm before. I do remember that. Okay. Let's see, what do we want here? We want result I equals array I. Great. What's next? Can we actually use left and right here? I'm not that sure anymore. Okay. Let's move on. So we have this misplaced element index. We want to move it to new misplaced element index. I'm not sure we can do that. Okay. Right, left. Okay, let's think. Let's just actually take one of this arrays. Haha, that's the same array that we used before. Okay, so we have -5 misplaced index, misplaced element index is 0, 1, 2, 3, 4, 4. New misplaced element index is 1. That's interesting. Our test cases miss 2 cases. One that will be on the right, the element, and let's say 5 will be here, just like this. So let's get them. Let's get these 2 tests. Misplaced element is rightmost, actually. Rightmost misplaced element and leftmost misplaced element. Okay, and what we have here, this array. And we just move it here. Okay, and let's move 3. Okay. How do we look for misplaced? We check previous, and it shouldn't work. It must be current. I see now. Wait. Okay, let me think. We start from 0, remove one element from the right. If current element is bigger than the next one, it won't work for the last element, so actually we can leave it as before. The only one thing here, we need to check the first element. If previous one is bigger than the first one, and we know that our array will have at least 2 elements because we have this condition. So if it's bigger, I don't want to turn on the lights. I'll be gray. Gray Alex. Okay. Previous is bigger than array 1. Return 0. Okay, this should work. Okay, let's get back here. So what do we want to do? We want to have another example. So index is 0. Where we want to put it? 0, 1, 2, 3, 4, 5. Okay, and the middle, like this. Index of the misplaced 0, 1, 2, 3. Where I want to put it? In 1. Let's move it here, or actually here. That's like a normal one, not the rightmost, the leftmost. So we want to first copy from the beginning, from 0 to the left one. It's minimum from this or this. So let's say it's -6. and then here is 1. So if 1 if left is new misplaced item, element index I mean, then we add I want to make it a while loop actually, or we can do it like that. Oh no, okay. Let's leave it as separate. Separate arrays. Separate loops. Okay. Result left equals array misplaced index. If it's not that, let's try one thing here. No, it doesn't work well. Okay. What does it mean? If left is not a new misplaced item, then it means that left is current. Okay. Okay. Current plus plus. Maybe we don't need to do anything here, we just need to increment current and that's it. Okay. So let's say we're here, we moved -5 here. And then we go next. We stopped at left. So it should be right minus left. Array left plus I. And here current plus I. I don't really like the way it seems, the way it looks. That's just a bit ugly. Okay. Just a little bit, so it's fine. Okay, so current plus I, which means we start from current. From here. And array left plus I. Array left is here. So we move it here. And right minus left. Right is 3 on this one. Okay. We have 0. Then we have 1. It should be less than 2. Okay, we copy 4. We have 2. 2 is not less than 2. We stop here. Or we can do it like that, I guess. I don't like it like that, but it's not good. So current plus equals right minus left. So we shift our current by 2. Here it was 0, 1, then 2, and then we shift it to 2, then it's 4. 0, 1, 2, 3, 4. It's here. Okay. Okay, let's look for this example, and here we have right. Right is 3. If right is misplaced item, misplaced element index, then sorry, my brain reset. Okay, so what do we want to do here? We want to just continue if it was the misplaced element. Then I want to continue for I and I less than array length right +1. Result current equals array I. Or we can do it like that again. Zero minus right -1. And here we'll have right +1 +0. And here we will have +I as well. And when we finish, we want our current to be like this. Actually, it should be the end of it, so it doesn't really matter what the current is. So we want to return array result. Okay. Merging arrays is not that easy, apparently. In C# at least. In Python, I guess it would be much better. Okay. We are here, we do it like that, I guess. No, wait a second. So right was the misplaced element index, 0 array length, 1, 2, 3, 4, 5 elements, minus right -3, it's 2, and -1, it's 1. We have 0, so current, I guess current is here. Current +0 is current equals array right +1, and it's 3 +1 is 4 +0 is just 4. 0, 1, 2, 3, 4, so we have 5. Okay, and we stop there. It works for this example, That's great. What about this one? Okay, we have a left, we have a right, we have everything we need. Left is still the misplaced item. Okay, so let's start here. Current is 0. Actually, I don't really like that. I think I want to do it like that. And here it should be just I. Oops. And also micro optimization. No, no, no. Please don't. Okay. Okay. So this is the first part. We just go from 0 to left, copying everything. Left is 1. So we go here, -6. And then we stop. Current equals left. Current equals 1. If left is new misplaced item index, and that's true because the misplaced item index is here, it's 4. New misplaced items index is here. Result left equals misplaced item, so it's -5. Okay, current plus it's 2. Let's move on. It's 2. Let's go here. Right minus left. 4 minus 1 is 3. 0 is less than 3. That's true. So current 2 plus 0 equals left plus 0. Left is 1. So 2 plus 0, it's 1, 0, 1, 2. It's 2. And left is 1, left 0, 1. So we move here. And then we switch to 1. 1 is still less. And then it's 4. Then switch to 2. 2 is still less. Then it's 5. Current was 2, but becomes right minus left. 4 minus 1. Okay. So it's 4 minus 1, it's 3. Current becomes 2 plus 3, 5. If right was the misplaced element index, Let's add another if here for now. If current equals array length, return result. So it works for this one. Let's check the last one. Left is 0. If while 0 is less than 0, we do something, but it's not, so we do nothing. Current is 0. If left is new misplaced element index, it's not, it's the old one. So we don't do anything, current just plus plus, it's 1. What's here? 0 is less than 5 minus 0. Then 5. Current plus 1 plus I equals array left plus I. Left is 0 and current is 1. So we move what? Wait a second. Yeah, that's a new interesting thing. Current plus I. It's 1. I see. I guess. Or not. Yeah, we want to move further only if it's the new places on the left. And left is not the new misplaced, it's just the misplaced element index. So we don't do nothing. We can use else and do left plus plus here. So left becomes 1, right is 5. Okay. Five minus 1 is 4. $156, almost 2 hours. Yeah. Okay, 0 is less than 4. That's true. Current is 0. Plus I is 0. Left plus 0. Left is 1. So array 1 goes to result 0. It becomes -6. And we come here. Array 2 goes to result 1. Okay, we don't need this here. Okay, it's 2. Array 2 becomes current 1. So it's 4. It's 3 here, 5 here, 5 there. Okay. We have 4. 4 is not less than 4, so it doesn't work here. Current is still 0. Current is right minus left, so it's plus 4. Current is 4. 0, 1, 2, 3, 4. That seems correct. Current equals length? No. Move on. If right is misplaced. Again, it's the same if left is new misplaced item. Oh no, it's not. Because we shift left here. Okay, right equals misplaced item. It's not. Right on once, no. Right is the place where we want to place it. That's how I think it should be. However, okay, let's solve one problem at a time. Let's move one step at a time. Okay, so we moved here and it's not there, so we can just move along and okay, if we do it like this, result current equals array misplaced element index. And then move on. This will be okay. I think we need one more case here. We can use this one. Okay, it's -7. Let's say 3. Okay, like this. Index of the misplaced item is 0, 1, 2. New index 0, 1, 2, 3. Actually, it should be 3. Left and right are still the same right now. Okay, left is 2, right is 3. So I equals 0 from 0 to left. Okay, 1, 2. I mean 0 and 1. Okay, we copied it. Current is 2. Left is new misplaced item. No, it's just a misplaced item. So we don't do anything here. We increment left. Left is 3. Okay. 3 minus 3 is 0, so we don't do anything here as well. Current plus 0 is still 2. And then, yeah, that's where we need to continue copying it. So it should be for a loop again. Not the best solution for merging. Arrays. Actually, I could use a range here. Just not used to use them. Okay, let's finish. We have current equals to and I guess it should be right minus current. Current plus I. Right is 3, and originally it's a new place. 0, 1, 2, 3. If it was like this, and then that would be 4, Okay, let's say it like that. Say it's like that. Then current would be 3 in this case. And it's not correct. Okay, I guess it's time to use the artillery. Heavy artillery. Okay, it's much simpler. Oh, yeah. I guess I found a way to make it much easier. Come on. Extract method. Return. Get sorted array. New misplaced element index ID. Just index. If what's that? I is not equal to misplaced index. Continue. Oh, I see. Or don't. So if I is misplaced item, we want to skip it. Okay, let's do it like this, like the usual way. Current plus I. So if it equals then I++ or not. No, then current. Oh, come on. It seems like I will need an offset here. Then offset equals 1. I plus offset. So this way we copy the first part up until the new misplaced index, the new index. Then we insert our element. Result new misplaced item equals array misplaced element item index. Then we copy the second part. I equals new misplaced element index plus 1 up until the end of the array. Oh my. Yeah. Don't code in the evening. It's better to do it in the morning. Okay. Here what we have. Okay, we have 2 cases, right? No, it's 3. Okay, if I is less or equal to misplaced element index ID, just index. And misplaced element index ID is less than new misplaced. Actually, this one was the correct check. Okay, result I equals array I minus 1. It's because we haven't yet reached the misplaced element, and misplaced element goes before the place where it should be. Okay. Else, actually, if I is bigger than misplaced element index, and misplaced element index is bigger than new misplaced element index. So if we insert in before it, then we just copy in the results I equals no, I don't really get it. It shows just result equals to array I. Like this. So what do we need here? We are moving from the new place. Let's use this one as an example. So what we did first, okay, let's calculate. Misplaced element item is 2. New misplaced element item index is 0, 1, 2, 3, 4, 5. Okay, so what do we do here? We copy everything before the new index, but if we reach the misplaced element index, we make an offset. So misplaced element index is 2 and this one's 5, so -7 -6, it's 0, 1, then we reach 2. 2 is getting offset to 1, so we get -4, -1, and here we have 0, 1, 2, 3, 4. New misplaced item is 5. That's interesting. I was 0. 0, 1, 2, 3, 4. We still need to copy. And here we copy this. It doesn't really work this way. Okay, so while it's less than the index where we want to place it, we copy everything. However, if we reach the element, we offset it. Should we use I plus offset here? No, wait a second. 0, 1, 2, 3, 4, 5. It will find 5. I guess what we need to do here is for the new misplaced element, have it -1 here. Give me a second. I think so. If new misplaced element index is bigger if new misplaced element index is bigger than misplaced element index, then new misplaced element index gets decremented. Okay, now let's see what we have. Zero is less than 0, 1, 2, 3, 4, 5. But here we decremented, so it's less than 4. Okay, we place -7 here. We go to 1. It's still true. -6. We go to 2. 2 equals the misplaced element index. 2 equals 2. So we have offset 1. So result 2 goes to 3. This one 0, 1, 2, 3 goes to -4. Okay, it's 3. 3 is still less than 4. We have offset already in place, so it's -1. Now it's 4. 4 is not less than 4, so we remove it. We go further. Now, new misplaced. It's 4 actually. 4 equals to misplaced element index 0, 1, 2, 3, 4. 0, 1, 2. So it goes here. Great. Let's say that we have 6 and 8 here as well. Okay, we moved past this one. Okay. Now what do we do next? Starting from the new misplaced index +1. 5 is less than length. 0, oh, just 1, 2, 3, 4, 5, 6, 7, 8. 0 or 5 is less than 8. Okay. Five is less than 8. Starting from 5. 0, 1, 2, 3, 4, 5. That sounds correct. What do we want to do? We want to just do it like that. Just result equals array, and that would be it. Okay. So let's pretend we have it like this. So we have 5 is less than 8. We copy I. I is 5. 0, 1, 2, 3, 4, 5. 5 to 5, it's 5. And goes to 6. We copy this. It goes to 7. We copy this. And we stop because it's 8. Okay, now it works. What about the other case? Let's say we have it like this. And somewhere here is -5. So new index is 0, 1, 2, 3, but element index is 0, 1, 2, 3, 4, 5. Actually. Oh, that's interesting. Which one of them will I take? I guess the latter one. Letter, right? Get misplaced element item. Yes, I return I, not the previous one. Okay, so it seems correct. Let's move on. New misplaced item is not bigger than misplaced, so we skip this. We have an offset set to 0. So 0 and NME is 3. 0 is less than 3. That's true. So we just copy it, -7. 1 is still true, -6. 2 is true, -4. 3 is not true, so we move on. We didn't reach the misplaced because it's 5 and we have from 0 to 3 only. Okay, we move on. We reached new misplaced element index and it's 3, 0, 1, 2, 3. And the misplaced index is 5, so we move it from 0, 1, 2, 3, 4, 5, -5 here. Oh, I miscalculated it a little bit. Let's say it's -3. That's okay. So we moved it. Let's move on here. 1, 2, 3, 4, 5, 6, 7, 8. We still have 8 elements. New misplaced item +1. 3 + 1 is 4. So we have 4 here. And we can't just copy. Here comes this condition. If I is less than misplaced element, if it's less than here, and misplaced element is less than new misplaced element index. No, that's not true. We don't really need this one, I guess. Okay, let's leave it aside for now. Okay, so 4 and 8. 4 is less than misplaced. Misplaced is 5. So result I is array I -1. So 4 and here is 3 and -1 goes here. -1. 5. 5 is less or equal to 5. So it goes here and uses 5. If not, then we just copy it. 6 and 8. Oh my. I hope it will work. Okay, why is it static? Okay, it can be static. Okay, return result. Finally, let's see all our tests. Run all. We have 2 new tests actually. Okay, waiting for build. 1. one test is broken, failed. Actually, not broken. Okay, 2 and 1. What happens here? Let's debug. Okay. Get misplaced element index. Pref is 2. 2 is bigger than 1. Actually, this one. So the misplaced one is 0. Okay, it doesn't really matter. It can be 0 or 1. New item index. So we have target 2 from 0 to 1. 0 is less or equal to high. Mid is 1, I guess. No, it's 0 actually, yeah. Array 0 equals target. Really? Okay. What should be? Low equals mid plus 1. Give me a second. Okay. I missed it somewhere, but it's fine. So what if we say it like that? Low equals mid. Okay, low equals high. Mid is 1. It's not equal. We should remove this equals, I guess. If it's less, then yes, okay. Low equals mid plus 1. Low is 2. Oh my. Low is higher than the number of elements. I don't think it's correct. let's do it like this. No, wait a second. Okay, it goes here, and law actually is 1. Okay. It's still not true. This case with 2 might be okay because we decremented it. Let's try it like that. Tests. Okay, what about other tests? Phew. I can't believe I spent almost 3 hours on this task. But okay. Finally it works, and we'll continue with this on the next stream. Okay, see you.